Hello, welcome to the video. In this lesson, we'll be looking at section 4.2, where we're going to be covering reflections. So more specifically, we're looking at reflections with respect to a coordinate plane. So one of the questions that we're going to have to answer is, how can we reflect a figure in a coordinate plane? Well, the first thing that we have to look at is where is our line of reflection? So we have to be able to answer that question. Where is our line of reflection? All right, so um, once we establish that, what we're going to do is when we make our reflection, it is a type of transformation where that is used a line like a mirror to reflect the figure. Okay, so we had 2 points here. So this was the original point P. We wanted the mirrored image of P prime. So in order to find um, the mirrored image of this, it was at this line, which was slope M. So the distance from whatever this is to whatever this is had to be the same. And more specifically, this line segment between P and P prime had to be perpendicular to the slope M. Had to be perpendicular to the slope M. Okay. Another thing to keep in mind is when you are making a mirrored image of something, if for some reason the point that you are trying to find, so you may have to find a series of points, but if a specific point is on the line of reflection, both P and P prime will be the exact same point. So that's what they're trying to establish here. So with that being said, let's try to find some reflections with respect to whatever the line of reflection is that they describe. So we have graph ABC with vertices 1, 3, 5, 2, 2, 1. For part A, they want you to find the reflection as n is equal to 3. So let's see if we can get a graph. Let's see here. All right, got ourselves a graph. So let's plot these points. So 1, 3, 1, 3 is my value for A. So I got 5, 2, 1, 2, 3, 4, 2, B, and then we got 2, 1, and we have C. All right, so to make it a little bit neater, I'll just use my line segment. All right, so here, and then here, and there. So here are my points ABC. They want us to reflect over n is, or x is equal to 3. So x is equal to 3 is a vertical line at x is 3. So I'm just going to I'll make it red so we can easily identify it. So here is so this red line is going to be our line of reflection. So what we now need to do is now we need to find what A prime, B prime, and C prime are. So A prime, B prime, and C prime. All right, so looking at this, to make this um, perpendicular, all I got to do is looking from A prime is going to be located right here because it's perpendicular here, which is horizontal. Any horizontal line segment is going to be perpendicular to a vertical line. And it's equidistance. It's 1, 2 from the red line, and here it's 1, 2 from the red line as well. And if we asked to find well, it's at 1, 2, 3, 4, 5, so it's at 5, comma 3. So A prime is at 5, comma 3. Next, I need to find B. So since B is 1, 2 from here, so I'm going to go 1, 2. So B prime is right here. And that is located at 1, comma 2. And then finally looking at C, it's going to be located right over here. That is C prime. And it looks like the coordinate is 1, 2, 3, 4, comma 1. All right, so if I make a line segment and I'll just make the color green because that's how I drew it. So it'll look here, here, and there. So everything's the same distance-wise. It's just flipped over a mirrored image on uh, along x equals 3. And if you looked at B, everything remains the same. You're just looking at now something where it's y is 1. So if you did that, real quick, so here y is 1 would be right here. So everything would then be mirrored image off of this red line. And if you want to know where those are, please leave a comment and I can certainly work out part B as well. But let's take a look at this one. So this one here, it says I have a line segment FG with endpoints negative 1, 2 and 1, 2 respectively. And it says, and its image after a reflection is at line y equals x. So if I get out my graph again and let's plot f and g. So negative 1, 2 is f and g is 1, 2, which is right there. Oops. I don't know why I wrote it 2. So here's our line segment. Now what we have is it telling us that my line of reflections at y equals x. So you got to resort back to your slope-intercept form, y equals mx plus b. My y-intercept is 0, so plot the point there. My slope is 1, so it's up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So hopefully we have. All right, so I'm going to make this, again, I'll make this a red line so we can relatively easily identify what that is. It'd certainly be better if you use a straight edge to, show accuracy and stuff like that. But now, trying to find the reflection of f prime and g prime, we need to find things that are perpendicular. So since this slope was 1, we are going to use a slope of negative 1 to solve these things. So if I went like down 1 to the right 1, that would get me g prime. And if I went down 1, 2, 3, I have to go to the right, 1, 2, 3, and this would get me f prime. Same distance, this is 1, 2, this is still 1, 2, so I didn't change the physical geometry of the line segment, I just moved it over my line of reflection. Some things to keep in mind when you're reflecting, especially over like the X and Y axis. So whatever original values you have for X and Y, if you are reflecting over the X axis, you're simply going to keep your your value of X the same. Y is now going to be the opposite. If it's reflecting over the Y axis, the opposite now gets changed with x, and y remains the same. Here it says if you have y equals x, what happens is the values of b and a switch. And if it's reflected as y equals negative x, then it's not only do you switch around the coordinates of x and y, but you also make them the opposite values. So keeping that in mind, so if we looked at this coordinate is at 2 comma 1, and then this coordinate is at 2 comma negative 1. So that makes sense. So that so at least it held true here. If we look at this one here, it says using that graph. So if I said that f was, negative 1 comma 2 and g was 1 comma 2, what they're asking now, oh, this is reflecting over y equals negative x. So if we go back to this rule, what you're going to do is you're going to flip around a and b, but you're also going to make them the opposite values. So that means that f prime is going to be negative 2 comma positive 1, and that means that g prime is going to be negative 2 comma negative 1. So here it says they're asking you to graph triangle JKL and its image after a reflection in the x-axis. So again, let's just look, graphing it is just, plot the points, but we do have the rules. So let's look at J prime, K prime, and L prime. So looking at these coordinates now, because it says it's over the x-axis, what we do know what we do know is that the x coordinates are all going to remain the same. So it was 1 in j, so j prime will stay 1. K was 4, that's going to stay 4. And L was 3, that's going to stay 3. What gets changed is your y coordinate, and it's going to be the opposite. So positive 3 for j, negative 3 for j prime. Positive 4 for k, negative 4 for k prime, positive 1 for L, negative 1 for L prime. All right. Same idea for 6 when I look for my J prime, K prime, and L prime. Now they're saying over the y-axis. All right, so y-axis, now those y values stay the same. So 3, 4, and 1. And what gets changed is our x. So this is now negative 1, this is now negative 4, and this is now negative 3. So in this particular example, they are using some of the things that we looked at in the first section with translations, but then they also want a reflection. So what we're going to do first is figure out what our translation points are going to be. So I'm going to call those A prime, B prime, and C prime. And all we are going to do is add what we need to add. So in this particular, we're subtracting every x value by 3. So it's going to be 3 minus 12, so I get negative 9. So A prime is going to be negative 9, comma 2. B prime is going to be 6 minus 12, though it's negative 6, comma 3. And then C prime is going to be 7 minus 12, which is negative 5, comma 1. All right. Now, what we're going to do is now we have a reflection and they're reflecting over the x-axis. So now the new name for this is going to be like A double prime, B double prime, and C double prime. Just because now we're making a second change. And because it's over the x-axis, all of my x values remain the same, so -9 remains the same, -6, and -5. What changes is the opposite, so it's going to be -2, the opposite, which is -3, the opposite, which is a -1. So my translation we took care of, and then with reflection, so my new point would be located right here. The last thing that we are going to cover is looking at lines of symmetry. So lines of symmetry, by definition, are when you have a figure and it can be intersected or reflected in a way where you almost be able to like fold it, kind of equally. So um, what we can say is this, looking at part A, using like a straight edge to kind of make it neat, I can cut it in half like this. All right, so that's one line of symmetry, and I believe I can cut it like this. So I could cut it in two separate lines of symmetry. So I would say that there are two lines of symmetry in this particular instance. If I looked at part B here, it looks like I could cut it here, which is one, and move it over a little bit. So that's one. I could say right here, which is two. I could go here, which is three, here, which is four, here, which is five, and here, which is six. So I understand it's a little bit messy, but you guys kind of get the idea. So there are six lines of symmetry in this particular instance. And then to finish up C, it appears like there is only one line of symmetry. And that is being able to look at reflections. I hope this helps. Until next time.